Hello guys, I think you can hear me, right? Can you just confirm whether audio and video is clear or not? Yeah, quickly confirm the audio and video. Yes, hi. Okay, I think clear, it's clear, things are clear. Okay, so yeah, Collywood Gallery, yes, confirmed me that things are clear. So welcome to the session. I think you know what we're discussing. We've been discussing about uh, MCQs, right? MCQs. As I said, the moment this video reaches to 500 likes or maybe 100, I'll go for the next video. Okay, you will get a next live session where we'll be discussing the continuation part of this MCQ. Okay, it's all in your hand. Hi, Kartikeya. Yeah, not clear. Okay, yes. Hi, Master. Hi, Bhuban. So let's begin the session. Today we got some theoretical questions. Okay, today we got some theoretical questions. We'll enter to the theoretical questions. And before I go to the theoretical questions, let me announce one thing. Already made earlier one session for the app. Okay, we recently launched an app, a new app for the guidance purpose. We launched an app. You check the link in the description and try to install that app, and you will get a lot more exciting rewards through that app. Okay, so go and get the app. Let's get to today's session. Okay, can we go to the lesson? Yeah, why not? Why not? And what about the questions? Do you have any questions before I start today's questions? Let's get into the question. I mean, if you have any previous questions, you tell me, you ask me previous questions. If you have any questions, I'll try to clarify those. No need of apps? Okay, don't install. It's your choice. If you want rewards, you install. If you don't want, don't install. You're the one who is going to lose. All right? Okay, do you have any questions? Hit the like button. Let's reach increase. Let me wait for some more time so that people will join, then we'll start the session. Okay, give it a thumbs up. Taste the thunder. Yeah, okay, so thank you. So you have no questions, right? It seems you have no questions. So with that note, with that positive note, very good note, I'm heading to the question. We have a question. Very useful. Okay, dear. So why an alternator did not draw an extra current when loaded as transformer? See, first of all, when I ask you for the questions, if you ask questions what I discussed in the previous lecture so far, because all the background I have given, right? If you ask those any queries on that, then it will be easy to interact, right, on that within a short time. But you're saying the question itself is not clear. Why it did not draw any extra current? Why it will not draw? It will draw extra current, definitely. Like kar do sab, yes, like kar do sab. Now, let's get into our session. Okay. Yeah. Had dinner? नहीं खिला दो भाई खाना नहीं खाया. So we're at the 10th part. Part 10. 9 parts I discussed. We are now at 10th part. There is some issue here. I'm unable to see that. I don't know whether you're able to see or not. मुझे तो नहीं दिख रहा है. देखा एक बार. 10 नहीं दिख रहा. Guys, I think there is a slight glitch somewhere over here. We're unable to see that things here. Okay. Some text is missing. Let me see. This is actually part 10, but I can't be able to see that over here. So anyways, let's see whether you're having the same problem in the questions or not. No, we're not having any issues here. So let me get to the questions directly. Okay, the problem is not here with the questions, but I don't know with Maybe different color. I think that color is not visible there. I don't know how we are getting it. Yeah, this is a question. This is a question number 81 according to the book. I'm giving you, I think 1 minute is enough for this. 1 minute is good enough for this. Yeah, look for your answers. Okay, answer it quickly. Answer it quickly. Let me give some options here so that it will be easy for you. Okay. I don't know. I'm experimenting with this now. Oops. What's wrong with this? Something wrong has happened, I think, maybe. I don't know. Catch a little bit. Yeah, we sign it. Mm-hmm. We have 4 options. I'm entering 4 options here. This is a hectic job. Anyways, time's up. Now you got the options. Uh, yes. So, what's the question? Consider the following statements. Okay. So, most of you answered option as 2, right? Okay, fine. Let's get back. Consider the following statements. If the terminal voltage of a DC shunt motor, I think this concept I discussed several times. Several times I discussed this concept in this series. Okay. DC shunt motor, terminal voltage has become 50%, half means 50%, with load torque varying as square of the speed. Okay, here the extra information what is given is load torque is varying as a square of speed. Okay. Didn't see that as well. Guys, can you see that T is proportional to n square what I written? What happened to my eyes? The white color is visible, but the other color is not visible. Can you guys figure it out that? Are you able to see what I written? I don't know what happened to it. Okay, anyways. No, yeah. Shunt motor is constant speed machine. Okay. Anyways, as there is a slight technical glitch, it seems. Just give me a minute. Okay. एक बार देख लो ये नहीं आ रहा. I'll be back. Okay. Just stay there for a few more minutes maybe. We got some simple questions in this session. Yeah. Yeah. Now we're set. We're set now. Thank you guys. Thanks to my team. fixed nicely. But you can see these things, right? Yeah. TL is proportional to n square. Okay, that's what is given. That's what is given in the question. Now, what is said? It is said in the options it is given, speed will become half. See here, when terminal voltage becomes 50%, for a shunt motor, both flux will reduce as well as armature voltage will reduce. Both will reduce. Okay. So we know the equation, N is proportional to EB by phi. Here, flux is reduced by 50%. If I ignore the losses, IR drop losses, EB also reduced by 50% because V, I can take this one as V. Okay. When IR drop is 0, if I ignore that, I can simply take it as V is equal to EB. Now both are reduced by same proportion, so speed will remains constant. Okay, speed is remaining constant. So speed becomes half. This is wrong. Okay. So when speed remains unaltered, when n is constant, so n square is also a constant, so torque is also constant. Okay. Torque is constant means we know torque in case of DC shunt motor, torque is proportional to phi into Ia. Okay. So phi has reduced by 50%. Maintain the constant torque, current has to increase by, current has to become doubled so that the product will be same. Okay. So flux has become half, so current will become twice. That's what, double. So this is correct. Armature current unaltered, that's wrong. So answer is 2 and 3. So answer is 3. Correct option is 3. Any questions in this? Any questions in this? Madhu, gaming? I think this guy having some fun here. Okay. Okay. Let's cut this. We have some things over here in the channel already. Things are there. This Madhu is trying to play something, I think. So he's out now. Okay. Let's go for the next question. 82. Yeah. Consider the following statements. You try this. You try this. Try this. You got 2 minutes time. It's not 2 minutes are not required for this actually. It's 1 minute is enough. Why have I given 2 minutes for this? It's just 1 minute question. Yeah, it's like multiple select questions. You need to select what is the right answer here. Obvious options are there. If the multiple select questions has to convert into MCQs, then they'll give this set of things. Okay. If you just look at it generally, it's a multiple select question. Okay. Select what is a right answer. You got 9 seconds. Let me avoid the distraction. Yeah. What is the answer you got? 2, 3. Okay. Any other tries? Anyways, as time is up, let me push. Ward-Leonard method. What is this Ward-Leonard method? Careful, because the questions, few more questions will be there based on this Ward-Leonard method of speed control technique, which is one of the most efficient at very costly method. Okay, but most efficient method but very costly method. So And the word Leonard method is suitable for constant torque drives. See, word Leonard method is useful for constant torque as well as, it will be useful for above rated speeds as well as below rated speeds. Okay, so it is for constant torque, which is below rated speeds. Okay, and constant power, yes, which is above rated speeds. If I just draw the torque speed characteristics of a DC shunt motor, okay, torque versus speed will be something like this. Torque will be like this, constant torque below rated speed. If I take this as a rated speed value, and beyond that rated speed value, torque will reduce. Okay, and if I draw the power versus torque characteristics, power versus speed characteristics, then power will slowly increase like this, and after rated value, power will be maintained constant. Okay, so word Leonard method is suitable for both above rated speeds as well as below rated speeds. Okay, and which is having a wide range of speed control. That's what the advantage of word Leonard method, and we can control the speed fine way, means very small increments of speed is also possible with the help of word Leonard method. Okay, this got choked. Yeah, I think now it's fit. So answer is these two are correct, 1 and 2 are correct, so 3 and 4 cannot be the answer. Okay, now as these two options are not having 3 and 4, you don't have to check 3 and 4. Okay, but you give it a shot, check it once. Field control method facilitates the speed control below rated speeds. No, field control method will facilitate the speed above rated speeds, and armature control method will facilitate the speed below rated speeds. Okay, armature control constant torque, yes, you can see this. Below rated speed is this area, above rated speed is this area. In the below rated speed area, torque is constant, right? Yeah, and this is wrong. Fourth one, armature resistance control method is more efficient than word Leonard method. No, in case of armature resistance control, you're including resistance value, you're adding certain amount of resistance. When you add certain amount of resistance, what will happen? It will dissipate the power, the system will be lossy. Okay, but in case of a word Leonard system, though we use resistances in the shunt winding, but we don't use the resistance in series with the armature. Nowhere in the speed control of word Leonard method resistance will be used in series with the armature. Hence, that's the most efficient speed control technique. Okay, so this is also wrong. Fifth one, field control method is suitable for constant torque. No, it is suitable for high rated speed. This is field control method. This is armature control method. This is suitable for constant power, like not constant torque. So this is wrong. So 1, 2, 6 is right. Answer is 1. Okay. Let's go for the next one. Next question. This is something tricky. Okay, but 1 minute is enough. You try. Yeah, 6 is also correct. That's true. That's what I marked, right? 6 also correct. Rohan. $16 seconds left. We have few more questions based on word Leonard method in this. Okay, time's up. So yeah, what is this? What's the question? The lower limit of a speed in a word Leonard method of speed control is governed by. Lower limit means what will what will affect the lower limit below which we can't, we can of course get wide range of speed control in case of a word linear method. Okay, just now I had drawn a graph. If I just use that, it will have below rated speeds as well as above rated speeds. Okay, so below rated speed up to what range can I get? If I want 1 RPM speed, is it possible to get? If I want 2 RPM speed, is it possible to get? Means what is a limit, a lower limit which is imposing for the word linear method? That's what the question. Understanding question is very important. Okay, so to answer this, we'll have to look for to have below rated speeds, armature voltage. Below rated speed means what? Armature control method will have to control armature voltage. Okay, so if armature voltage can be, if the armature voltage can be 1 volt, 2 volt, 3 volt, any such voltage, means for very small, if you can get small voltages like this also, 1, 2, 3, 4 like that also, then we can control the speed to very less value. But is it possible to get this 1 volt, 2 volt, 3 volt for the motor which we are controlling, the main motor which we are controlling? Main motor as in word linear method, what will be there? In case of word linear method, you will have a main motor. Okay, our objective is to control the speed of this motor. Okay, so for that, what are we doing? We are connecting this main motor through a generator. Through a generator, I am connecting this main motor electrically. I am supplying to the main motor through a generator. Now, to drive the generator, to run the generator, to mechanically move the generator, you need to have a prime mover, right? So there is a prime mover which is coupled to this generator, which is another motor, and this motor will be supplied from another supply again. Okay, this is supply, this is having another supply which is driving this generator, and this generator will induce some voltage. That voltage will be given to this. Okay, and obviously everything will be having its own field windings. Okay, this is what the structure of word linear method. Just to drive this, just to have a speed control of this motor, we're using this entire arrangement. That's why it is saying, I'm saying it's costly. Okay, now by using this get setup, can I set here 1 volt value, 2 volts value? Yes, I can set, provided if I can control the speed of this motor to very low value. If I can control the speed of this motor to very low value, then I can get very small voltage. Okay, so point is, speed of the generator prime mover will have, definitely will the key aspect to what lower level you can go up to. Okay, and armature circuit resistance of both the machines, it's not exactly armature circuit is a key aspect there. Okay, but yes, I can consider armature circuit resistance, because as a resistance is more, the voltage what we are getting here, what is applied to the armature winding will be affected, though it is a small effect, but yes, there is a slight effect. Okay, let me just, yes, this can be the possible option. Okay, so, but how much will be the change? Change is very small. Okay, and residual magnetism of the flux, residual magnetism of the generator, yes, residual magnetism will have an effect definitely, because that itself will initiate the build-up of voltage. That will, if the voltage is, if the speed is too low, then, or if we can say armature flux, this is having a field winding, this generator is having a field winding, but even though this current is reduced, but some residual flux is present here. That residual flux, suppose let me take it as some milliwebers flux is already present. Okay, then that will produce certain amount of voltage. The voltage cannot be below that voltage. Okay, all the time residual flux will be present, because of, even the current is 0 here, IF is 0, there will be some flux. Okay, so the point is, this is, yes, strongly, this will limit the lower limit. Okay, so I can say 214 strongly, 3 is also there. Yeah, we have an option So I'm just choosing 2, 3, 4. If I don't have an option 2, 3, 4, I would have chosen 2 and 4. Now losses of the machine. Losses of the machine means it will have mechanical losses, it will have shunt field losses, all these losses, they won't come into picture, okay, for the speed control. I think you got it. It's actually a lot of analysis here you need to go for. Once again, you go back and check it. The main concern here is, main point here is voltage, lower limit of the voltage, because voltage is the one which is controlling directly the main motor speed, okay. So who is limiting the lower value of the voltage? Those are the aspects you need to see. That's it. Okay. Okay, next question. I'm moving to the next one. Yes, this is an interesting one. Try this. I'm giving 2 minutes for this. Yeah. You got 2 minutes to go. Let's see. I think these options 3 and 4 are unable to see. Okay, you read the question, you put in the right sequence, that's it. Or should I zoom out a bit? I think now you can see. 56 seconds more. Today we have mostly theoretical questions with a bit of concepts. You're trying or not? I'm waiting for you. Hi, hello, Syed. Syed. Rohan is saying 4 is correct. Okay, let's see. Who else will respond to this? Okay, 2, 3, 1, 4. Okay, time's up. Let's see. Try to understand the question here. Try to understand the question. The question says, DC shunt motor is running on following conditions. Okay, it's running. Okay, let it run. Then, if it is running, what's the problem? The problem is it's running in 4 different cases. Okay, it's running in 4 different cases. Now we need to see the speed in increasing sequence. Means what is the highest value of speed, and increasing order, what will the speed in increasing order? That's what we need to see. Okay, let's check it out. Normal voltage with no additional resistance in the armature or field circuits. Okay, we applied normal voltage, means some voltage we applied. Okay, rated voltage, let's consider rated voltage is applied. No resistance is added in the armature as well as in the field. Okay, then it will rotate at some speed. Let me consider for the sake of better understanding, I'm considering the speed here is 1000 rpm. Okay, you can consider any number, I'm just considering 1000 rpm. Now in the second case, what happened? 50% of the normal voltage, 50% of the normal voltage with no additional resistance in the armature or field circuits. It's a shunt motor. The input voltage is itself is reduced by 50%. The input voltage itself is reduced by 50%. I told you in the just previous questions only, I told you speed, if the terminal voltage is reduced by 50%, there won't be any change in the speed, because the equation also I given, right? N is proportionality. If I ignore the armature resistance drop, then it is EB by phi actually. so I can write it as V by phi. Okay, both voltage is reduced as well as flux is reduced, so speed will be constant. Okay, if I ignore IARA, that's a key point here. If I don't ignore IARA, things will be a little different. Okay, it's actually V minus IARA, terminal voltage minus IARA. Okay, so I can say it is approximately close to 1000 RPM. Okay, it's approximately close to 1000 RPM. Okay, of course a little less than 1000 RPM, but yeah, close to 1000 RPM we can say. Next, normal voltage with a small external resistance in the armature circuit of value equal to the armature resistance means we're applying a full voltage, rated voltage, but there is a small external resistance in the armature circuit. Means it is an armature control speed control method. Armature, by adding an external resistance, what will happen to the speed? Tell me. Speed will reduce. Armature control method, speed is reduced to what value? Some value. So I'll take this one as less than 1000 RPM because I'm adding external resistance in series with the armature, means speed will reduce. If you add external resistance in the field circuit, flux will reduce. So with this relation, speed will increase. That's what this case. Nominal voltage or normal voltage with additional resistance in the field circuit. So the speed will be greater than 1000 RPM here. Okay. So now we got the numbers here. So this is the highest speed what we got. So increasing order, these two are wrong. 2 and 3 is wrong. Okay. At the end you must be having 4. And what is the lowest value? Lowest value as far as my analysis, it is 3. Okay. 3 is the lowest value. Then you're having 2, then you're having 1, then you're having 4. Okay. These were the sequence according to my analysis. But as the option, see here, it is not clearly said it is also less than 1000, it is also less than 1000. These two are interchanged in the options, it is given like that. So as the options are given like that, so I'm just picking this because 1, 4 is final for me. Okay, this is 1000, this is greater than 1000. These two are less than that. So by keeping these 2 points in my mind, I'm just marking this. Okay, if here I would have got 3, 2 and 1, 4, I think, let me just analyze here. Yeah, if I would have one more option, suppose option 1 as, if I have option 1 as 3, 2, 1, 4, I would have picked option 1 as the right answer. Okay, but from the options what is given, I am picking option 4. Okay, hope you got a point. Yeah, are you having any question here? Tell me. If you don't have any question, then I'll continue further. Yeah, is the analysis clear? What I said? Huh? What do I? Are you guys are there? If you are watching on rebroadcast, just check, give it in the comment. Okay, we'll check in the comment. Give it in the comment so that we'll be knowing the analysis is clear or not for you. Okay, no. Okay, Praveen. According to you, what is the right answer, Praveen? What do you think? What is the right answer? According to you? Here we have 2 things. As field flux is resistance is added in the flux, field winding means flux has reduced. As flux has reduced, speed will increase. Okay, I'm taking that increase in speed as more than the normal speed. Normal speed I have considered as 1000. So it is more than 1000. So it is some value more than 1000, 1100. Let me take. Okay, and with the analysis we got, these two will be close to 1000, actually less than 1000. Okay, approximately I'm saying. So this is definitely less than 1000. This option 3 is definitely less than 1000 because you're adding a resistance in the armature. Okay, that's what armature control method. I think once you know these, see, you should have a basic understanding. When you're coming to the MCQ sessions, means what? You're not learning new things here. Okay, you're not learning completely the basics you should be having. From the basics, you're building up the things. Okay, once you know the basics of speed control methods, then definitely you'll understand these concepts. Okay, yeah. See, the objective of this is not to explain everything from the scratch. Okay, it is to sharpen or shine your existing knowledge. Okay, check your existing knowledge rather. Check this question. Check this question. I think 1 minute is enough for this. Try this one. Oops. We got 2 minutes. It happened to become 2 minutes. You're saying option 1, Praveen? Yeah, you got 30 seconds more. Okay, time's up. Time's up. Let's see what is given in question. In the question it is given, you need to control the speed of a DC shunt motor above rated speeds. It is given, you need to control the speed of a DC shunt motor above rated speeds. When you want to control the speed above rated speeds, you guys tell me, I should go for armature control method or flux control method. I'm asking a question. Tell me whether I should go for armature control method or flux control method. Again, we got a slight technical glitch. Just, I'll be back in a minute. Meanwhile, you give it in the chat. Okay. Yes, you're absolutely right. It is a flux control method. We'll be using flux control method to increase the speeds, okay, above rated speeds. To have speeds less than rated speeds, you'll go for voltage, reduction in voltage, okay. So when you reduce the flux, when you reduce the main flux, to be more precise, when you reduce the main flux, effect of armature reaction will be more. Effect of armature reaction will be more on the main field flux. Okay, that's what armature reaction, right? What is armature reaction? The effect of armature flux on the main field flux. Now the main field flux has become weak. Why it has become weak? You made it weak because you wanted more speed. As you wanted more speeds, you have reduced the main field flux. Now the armature flux is become dominant. It will oppose the main flux too much. The effect of armature flux on the mix is more because its value is weak. Okay, so that will lead to poor commutation. That will lead to poor commutation. Okay, that will give sparking at the brushes, poor commutation. That's what is poor commutation, right? So to improve the to improve the commutation, to avoid the poor commutation, and to reduce the armature reaction effect, I am using compensating winding so that armature reaction effect will be reduced, the cross magnetizing effect will be reduced, and to reduce the sparking at the brushes because of the poor commutation, I'll have to use interpole winding. Okay, I'll have to use interpole winding. And the main thing, we must use 4-point starter for the below rated speeds. And this was one of my interview question when I was appearing NIT. There, professor asked me this question when I was appearing for my post graduation. They asked me this question that there at that time interview was there. Okay, so professor has asked me what is the difference between 3-point starter and 4-point starter. This is one of the question. The other question was, you try to give it in the comment. The other question what I got, the ceiling fan was there. Ceiling fan, professor asked me, what is a capacitor rating? What is a capacitor, what we use in a ceiling fan? He asked me first the purpose of capacitor. Why we are using, in case of a capacitor split phase, we use a capacitor, right? So what is the purpose of having a capacitor? Then I said, this is the purpose of having capacitor. Then he asked me, what is the rating of that capacitance? What is the voltage rating of the capacitance? Okay. Can you tell me what is the voltage rating of that capacitance? Voltage rating of that capacitance is not 230. It is 400. Generally, it's 440. He asked me then, why is it 440? Okay. That's a question for you. You try answering that. Give it in the comment. I'll see. Okay. Question was, why we need to go for the supply voltage 230 volts? Then why we need to use 440 volts capacitor there? That's the question. Okay. So anyways, so the 4-point starter, the advantage of 4-point starter, the reason why we are going for 4-point starter itself is for below rated speeds, so that no volt coil will not be released when you reduce the flux. I think once you know the 4-point starter operation, you will answer this. So 1, 2, 4 is the answer. So answer is option 1. Okay. 230 volts is wrong answer, Rohan. Let's go to the next question. I think you can answer this one easily. Question number 86. Try this. 1 minute is good enough for this. I knew the answer. I could say the answer just because of my diploma background. Okay. And during my diploma, we get to expose to these kind of stuff. So I could answer there. You try. That's going to be interesting. Most of the people doesn't know. They don't even know that capacitor what they used is a 440 volts rating. Yes, it is. It's not necessarily for ceiling fan what you use. Any single phase motor you take, any single phase motor, submersible pumps, single phase motor, whenever you're using split phase motor, there you check it, the water pumps, centrifugal pumps, those also single phase will be having 440 volts capacity, voltage rating. Okay, anyways, the shunt motor delivers the rated load power. I always say, it is saying rated load power. Power is rated. Okay, rated torque is different, rated power is different. You need to consider them differently. Okay, and rated speed, rated power, rated speed means rated torque. Okay, because speed is equal to, we know the relation between power, speed and torque. Power is equal to omega into torque. Okay, so if these two are rated, obviously torque is also rated. Okay, so if the terminal voltage is reduced to half, yes, we got it. We neglected saturation here, we neglected armature reaction. When you neglect saturation and armature reaction, just now I said in the previous questions, if the terminal voltage has become half, tell me what will happen to the speed? Speed will maintain constant. That was clear, right? So speed maintains constant. Okay, speed is constant. Speed becomes both. Yeah, speed is constant. Speed is double. So this is wrong answer. Okay, just by looking at Speed option, I reduced one option, that is 4 is wrong. 4 cannot be the right answer. Okay. So as speed is constant, you will have, as speed is constant, speed is still rated speed. Okay. So voltage has become what? Voltage has become half. Means EB also, if I ignore IAR also, EB also have become half. Okay. Speed has become half, EB has become half. And we know as voltage is reduced to half, flux also reduced to half. Okay. When flux also reduced to half, to produce a rated torque, we know torque is proportional to phi into Ia. Flux has become half, current has to become double. So Ia is double. Anyways, this is gone. Ia is double. This is right. Ia is double. Yes, this is also possible right answer. But torque is constant. Here torque is given as torque has also become double. So torque is constant. To maintain torque constant, Ia becomes double. Okay. Torque is double. That's wrong answer. Okay. Here torque remains constant. Speed, yeah, all are constant. No. Current has to increase. Current will increase and it will maintain the torque. Okay. So answer is 3. See, it's all interlinked things. Things are interlinked. You need to go in a proper sequence. Okay. Once you have a basic understanding, then these things will be very clear. Okay. Now, obviously, if you don't know the background stuff, directly if you expect you will be answering these questions, only God can save you. Okay. Yeah. Now, this one, try this. This is a simple one, but very tricky one. Most of the students will not answer it, though it is a simple one. You try this. Try this. It's a simple one, yes. But you overthink. The moment you start overthinking, it will go wrong. Okay. Don't overthink. 30 seconds more you have. Yeah, quick. We got 3 more questions simply. Just 3 more questions. When you're watching a rebroadcast, check. Give your answers in the comment. Give your answers in the comment. Like this session and share the session with your friends. Rohan is responding nicely. He's saying 1 is right answer. Okay. Actually, this is expected. This is expected. People would say series winding is overloaded. But once you draw the diagram, then things will be more clear. You try again, Rohan. Rohan, you try again. Not Rohan, it's Roshan. In a long side, I read it as Rohan. Roshan, you try again by putting the same thing on a paper. Now you will get the right answer. Okay. If you don't put on a paper, then you will be trapped, and you are actually. Okay. Let me bring it up. So it is a short shunt configuration. If it is a long shunt configuration, your answer is right. Okay, Roshan, your answer is right if it is a long shunt, but it is a short shunt. If it is a short shunt, we have like this short shunt configuration. If I draw, it will be something like this. Okay. Now what has happened because of a overexcited guy, he has connected in place of shunt field. If it is series field. In case of series field, it is a shunt field. It is like this. And we apply 230 volts. Now the moment you do this, what will happen? Most of the motor will not run. Motor will not run, that is for sure. Why it will not run? Because this resistance is very high. So most of the voltage out of 230 volts, 220 volts is dropped over here, and remaining 10 volts, maybe 10 volts. If not 10 volts, maybe 2 volts. Less than 10 volts, maybe 5 volts, because this resistance is very small. So maybe it is 225, only 5 volts will come over here. Okay, so 5 volts across this armature and series field winding. So current flowing in this is very small. The voltage across the armature is very small. It will not drive even into the torque. Okay, so as it is asked about the overload, nobody will overload. Neither series field winding is overloaded nor shunt field winding, because both are having their respective voltages. Okay, are we clear? No, not B. It is 4 is the right answer. I hope you got Roshan. Any doubt in this question? This is a simple question, at a tricky one. Okay, this is just a tricky one I'm saying. Okay. Okay, nice. Let's move to the next question. This is again a simple one. Take 2 minutes. Try this. Consider it as MSQ, multiple select question. Okay. So what is the correct one among these 5? Just select the right ones. If you want to convert it as MCQ, these are the MCQ options, respective MCQ options. Good, Sachin. Why other guys are not responding today? Install the app. You will get a lot more interesting sessions in the app, special sessions in the app. Okay. This simple one. Though I have given 2 minutes, don't think that it's a tough one. It is a simple one, theoretical one. I told you, right? Previous lectures, previous parts were having a lot of interesting numericals, good analysis, but these are all theoretical questions. Okay, mostly. Yeah, no options yet. Arre yaar. 2, 3, 4 are correct. Okay, let's see. First one, direction of rotation of shunt motor can be reversed by interchanging its supply terminals. No, if you interchange supply terminals, we know torque is proportional to phi into Ia. Both Ia and flux current directions will change. So minus into minus will be plus. So if you interchange both the terminals, it is still the same direction. You cannot interchange like that. It's wrong. Either you'll have to change either armature terminals or field terminals. Okay, so direction of this is true. 4 is true, not 1. Okay. DC series motor should never run at no load. That's true. Absolutely true. So this is wrong answer. Okay. This is also wrong answer, because 4 and 5 are true. 4 and 5 are here, and 1 is wrong. 1 is wrong. 4 and 5 are right. So either 2 or 3 is the possible answers. Okay. Now let's check. Let us check. Yeah, this is also wrong answer. 2 is also wrong answer. Why 2 is also wrong answer? Because 2 is having option 1. Option 1 is wrong. So this is wrong. So correct answer is, this is the correct answer. Without even checking these 2 aspects, we got correct answer as this. But let me check this. This is what? Additional resistance in the field circuit of a shunt motor decreases. No, it will increase the speed, not decrease. Previously I had discussed. Additional resistance in the field circuit of a shunt motor increases armature current for a constant load torque. Yes. For more than constant load torque. Yeah, just a minute. Additional resistance in the field circuit of a shunt motor increases its armature current. Yes, it is increasing armature current for a constant load torque. Okay, when it is a constant load torque means what? Torque is constant. So if I increase resistance in the field circuit means flux has increased, flux has reduced. When flux has reduced, to maintain the torque constant, current has to increase. It is said in the question, it is said I need to maintain constant torque. To maintain constant torque, you have to increase the current because flux has reduced. Okay, so this is right. So 3, 4, 5 are correct answers. I think, Roshan, you're clear? Let me move to the next one. Next one. Let me give, I think 1 minute is enough for this. Yes. Go ahead. Recording capacitor rating when starting winding is removed due to the inductive nature. Fuse voltage will be developed across capacitor. No, that's not true. For regular operation itself, it is happening, not when abnormal condition is coming. Okay, you're talking about as a safety, if there is an abnormality, it will handle it. Is that what you're saying? That's not the case. Anyways, you try. You just got the question right. So try in different possible ways. Not just Roshan, everybody, every one of you, because this could be possibly your upcoming interview question when you are sitting in an interview, okay, when you're experiencing an interview. So you need to get ready with the answers. Anyways, I'll discuss also. I'll also discuss. I'll make a video on that because I've been making Y series question, right? Why 50 hertz? Already all these videos are done. Why 50 hertz? Why 11 kV? Okay, all these videos are done. And why 11 kV? Lot many people are having controversies regarding that, but I'm still sticking to that. Okay, I know what they said. I know my research team. They gathered a very nice piece of information. Okay, so if you want to state something, don't give it in the comment. Talk to me. Okay, let's discuss. Then I'll convince you. Okay, if you are thinking, some people will be thinking their own thing in their mind and they're putting up, it can't be right. Okay, and I don't want to argue with such kind of things. If you are good, if you're ready for the discussion, that's fine. But if you're ready for the argument, I'm not. Okay, we are not ready there. Yeah, time's up. A separately excited DC generator feeds a DC shunt motor if the load torque on the motor is half. Okay, this is separately excited DC generator feeding a DC shunt motor. Okay, we have a DC, like it's just like oddly node method. Okay, if the load torque on the motor has this point, some people will have some crazy questions. Sir, I have a motor. To the motor, I'm connecting a generator. I have a fan. Fan is rotating. I'm connecting a generator coupling to that. The generator also will freely generate EMF. Some concept, crazy concepts people will come up. This question is going to answer those kind of crazy questions. Okay. So separate excited DC generator is feeding a DC shunt motor. Okay. Now if load on the DC motor reduced become half, suppose you have, if I draw the circuit, we have a generator and it is feeding a motor. Okay. Now motor torque has become half. Motor torque has become half. When the motor torque has become half, obviously motor current will reduce. Motor armature current will reduce to half because load has become half. Motor current also will become half. Who is feeding this motor current? Generator is feeding this motor current. So generator current also will become half. Okay. So armature current of both motor and generator are half. Somebody answered already? Yes. Shiny, you're absolutely true. Let me end the session with one more question. Okay. We have one more question. This is a task for you. This is a task for you. You try doing this. Okay. You try doing this and give your answer in the comment. Okay. I'm not going to discuss this task for you. You give the answer in the comment. That's it. That's the end of this session. Okay. I hope you got, of course, this session here now, what I discussed is basic things. I have not discussed very deeper mathematical stuff here in this session because the questions are like that. We're going a sequence. In that sequence, we got easy questions this time. Okay. So let's see. We'll meet in the next session with some very interesting questions. And your task is, I given a previously just one question, right? Question number 90. That question number was 90. Give the answer in the comment section. Okay. Have a good time. Bye bye. See you in the next session. And for us to have next session, means if you want us to have next session, what is the task? You should share this video with your friends and hit the like button. Okay. Whether you like it or don't like it, hit the like button. We'll go for next session. Okay. Thank you. See you in the next lecture.